What is up, guys, and welcome back to another video. Today, we're going to be talking about the geometric mean. So lock in. I know this didn't go great in class, but I just made it a little too hard for no reason. It's really not that bad. We're just going to apply it in this unit. I'm going to keep it as simple as possible. So, bear with me. And let's see. Sorry, let me get my video set up. There we go. Still sick. It won't go away. I don't know why. My voice is back, though, so that's a good part. So anyways, the geometric mean. Now, the mean beforehand. Before this, you've heard of a mean, of a particular mean. Let's see. It looks something like, maybe you've seen that like A plus B over 2, right? Like, in this mean, you add up how many things there are, or you add up the things, and then you divide by how many there were, and we'll say that's equal to X. This is the middle. If you want to know the middle of a data point, of a data set, this is the middle, depending on the data set. All right? The geometric mean is a different kind of middle. This is typically called the arithmetic mean. Actually, that might be an E. I might have spelt that wrong. I don't know. It's pronounced arithmetic, but it might be arithmetic, right? Like, as in arithmetic. Anyways, it's the arithmetic mean. It's because you add and then divide. In the geometric mean, you multiply the things, and then you take the power of how many there are. So for us, there's only going to be two things. So it'll be x squared equals AB, all right? And then to solve for x here, if you want to know the geometric mean itself, you have to take the square root of both sides to get that A and B, which are both positive numbers, so that this happens. You can use negative numbers and find the geometric mean of imaginary solutions, but in geometry, they just don't make sense. Like, we just don't need them in geometry, so we won't be using that. Alrighty? A and B are called the extremes, and X is called the geometric mean. Alrighty? The reason it's called the geometric mean, if you can imagine, it's because it comes up in geometry, but the reason it's called, or the reason you might use the geometric mean, is like in a normal data set, if you have a bunch of points and you want to find the middle, you might guess that it's like right here. But let's say that, I don't know, we're talking about some kind of statistic in which you can drop out suddenly, something like that. The geometric mean can help you determine, like, maybe these upward going points are more important or something. So the geometric mean can weight itself higher or lower depending on how you use it, right? It's used a lot in genetics because there's really low chances that things happen in genetics, and it's used a lot in population growth. All right? That's because, like, the population grows so quickly that finding the middle of something, you don't want to look in the perfect middle. You want to look closer to, you want to weight yourself towards the higher number. Alrighty? In any case, we'll see an example of what I mean real quick. Let's try with the numbers 4 and 16. Okay, so if you were to find the middle of these numbers, the middle, using the arithmetic mean, is 10. 4 plus 6 is 20. 20 divided by 2 is 10. All right? But furthermore, if you take 4 and you add 6, you get 10. But if you take 10 and you add 6, you get 16. Weird, okay? Well, the geometric mean is just like that, except it's multiplicative. All right? Now, the number you multiply by doesn't matter. Just like the number you add doesn't matter. Okay? So, for example, what number do we multiply by? And then we can multiply by that same number to get 16, and we end up at a mystery number. So I challenge you, think about this. What number is in the middle if you're multiplying? Alrighty? In this case, the answer is 8. Alright? You could have used the geometric mean to solve for this, and we'll do that in just a second. Alright? But the reason is, if you multiply by 2, if you multiply 4 by 2, you get 8. If you multiply 8 by 2, you get 16. So 10 is the arithmetic middle, 8 is the geometric middle. And in this case, that we use the geometric mean, since we used it with numbers greater than 1, the geometric mean has found 8, which is closer to 4. But like, earlier I said, this will happen if you have numbers less than 1. Alrighty? Anyways, we can calculate 8 using the geometric mean. We could say 4 times 16, the square root of AB. Alrighty? And we say this would be the square root of 64, which is, of course, 8. Beautiful. That's all there is to it, ladies and gentlemen. We will, in the future, use this to solve things on triangles. And actually, in class, we cut out triangles from paper to prove the geometric mean first. You don't have to, though. Let's continue on and try some examples here. Alrighty, number 1 we got. And guys, I'm going to go slow and do everything. So if you want to speed up the video, slow down the video, whatever, that's up to you. Skip through it, skip back, reverse. That's on you, chief. So, ladies and gentlemen, what I'll say here, the geometric mean here, let's say 6 times 30, all right? And so this is literally it. Like, this is the answer. This is technically correct. Like, this is all you do. This is a geometric mean. But we want it in simplified radical form. So remember, the name of the game for radicals is pairs. So I spy a factor of 30 that makes a pair with 6 because there's another 6 in 30. So I'm going to write this as 6 times 5, right? 6 times 5 is 30. And then, since we have a pair of 6s, 1 can come out of the radical, and the 5 remains. The 5 has no friends, so he's lonely in jail forever. Unfortunately. Very sad. Sad day for 5. All right? Same thing for this problem. Let's try again. We got x is equal to, let's see, the square root of 16 times 28. Very cool. Here, I see that 16 is already a perfect square, but furthermore, there's a 4 in 28. So what I'm actually going to do, I'm going to write this as 16 times 4 times 7, since 4 times 7 is 28. Alrighty, and then here, 16 and 4 are both perfect squares. This is a pair of 4s, right? 16 is a pair of 4s, and 4 is a pair of 2s. So if there's a 16 in your radical, a 4 gets to come out, so 4 times. And then since there's a 4 here, a 2 gets to come out. And then we'll leave 7 on the inside, so we get 8 root 7 for our answer here. Alrighty? And since I have a little bit more space, you don't have to write this if you don't want to, but I'm just going to demonstrate something. Okay, remember that the geometric mean is in the middle of these multiplicatively, even though there's a square root here. In fact, the square root is necessary to ensure this happens. So check this out. Oh my God, excuse me. If we take 28 and divide by 8 root 7, we get here. So I'm not going to divide 28 by 8. What I'll instead do is divide 28 by 7 and then put my square root back in the top. Alrighty, so 28 divided by 7 is 4. So I'm going to have 4 root 7 over 8. Okay, this is called rationalizing the denominator. Okay, all I did was multiply by, and remember, you don't have to know what I'm doing in this step. I'm just showing you that something happens. I promise this is true. Okay, which leaves us with root 7, that's supposed to be a 7, over 2. Alrighty, root 7 over 2. If you multiply by, the way I did this here is by multiplying by root 7 over root 7. I just rationalized the denominator, same as the last unit, okay? And then I only went fast there because I don't have a lot of room. And then here, let's see, I'm going to do, our geometric mean we found is 8 root 7, so I'm going to do 8 root 7 divided by 16. And sure enough, do you guys see that 16 divides 8, and we're left with a 2 on the bottom, and we get the same thing. Okay, so what I'm saying is, multiplicatively, 28 and 16, this weird number, 8 root 7, is perfectly in the middle. Okay, so this is just a proof of that. I'm just kind of showing you that over here. This is the answer. Okay, just so we're aware. It's just that the middle is this weird, ugly, disgusting number, root 7 over 2. Anyways, so for the final one here, we'll do x is equal to the square root of 12 times 50. And here I'm looking for pairs, so let's write it out. We got 3 times 4, and then in 50, we have a 2 times 25, It's quite nice. Okay, so 4 is a perfect square. It's a pair of 2's. 25 is a perfect square. It's a pair of 5's. So we'll have a 2 times 5 on the outside. On the inside, we'll leave 3 and 2. Okay, so these guys are perfect squares. They come out. 3 and 2 left on the inside, and we have root 6 here. So we have 10 root 6 for our simplified form. Very nice. And guys, the reason we like simplified form is because you can do algebra with it like we did here, and it gives you an exact answer. It's easy to look at these two numbers and tell that they are exactly the same. Okay? Now that is the geometric mean. I'm going to come back, since it's already 10 minutes, I'm going to come back in another video and do this one.